Hi, Mr. Richards here, and as we look to end our month of March here in Ohio, where we're recording this today, it's snowing like crazy. And you wouldn't really expect that in March in Ohio, but hey, the winter of 2013-2014 has been one of the snowiest, coldest winters we've ever seen here, at least in the last 30 years. Today's lesson is on compare populations. Our objectives are to compare two populations using the measures of center and variability, and to compare two populations when only one is symmetric. Let's first start off by defining a box plot and double box plot. What are some characteristics of the box plot? It uses a number line to show the distribution of a set of data. It divides data into 4 parts using the median, and quartiles. Now, a box is drawn around the quartile values and then whiskers extend from each quartile to the minimum and maximum values that are not outliers. Sometimes you may have heard this called a box and whisker plot in the past. And so you might just see something drawn a little bit like this. I mean, that's an example of a box plot or a box and whisker plot. And then what the double box plot or double box and whisker plot does is it graphs another one on the same number line. So that way we can compare two populations. So we can write that a double box plot consists of two box plots graphed on the same number line. And here is our key for today. You can draw inferences / make conclusions about two populations in a double box plot by comparing their centers and variability. And that's what we look to do today. The double box plot shows the money raised during a walkathon. Compare the centers and variability of the two populations. Write an inference you can draw about the two populations. So we have our double box plot with walkathon money raised with the 8th grade and the 7th grade. And first, let me draw your attention to this box. The most appropriate measures to compare centers of variation. Now, if both sets of data are symmetric, you'll use the mean and mean absolute deviation. If only one set of the data is symmetric, you'll use the median and interquartile range. If neither set of data is symmetric, like we have in this case here, we'll use the median and interquartile range. And so as we look to compare our 8th and 7th grades, our 8th grade here, our 7th grade here, the way a box and whisker plot works, or we have our minimum, our maximum, and then the box goes around the 1st and 3rd quartile, and the dot in the middle, that's our median. And so when we look for the median of the 8th grade, that's going to be 20. And if I look for the median of the 7th grade, that's going to be 35. What about the interquartile range? Again, the box goes around this interquartile, if you will. It goes around quartile 1 and 3. And so what we need to look at is, well, this is 25. This is 15. So for the 8th grade, the interquartile range is 25 minus 15, or just 10. What about the 7th grade? Well, we have from 40 to 25. So 40 minus 25 will get us an interquartile range of 15. Now, it is good to know in this question all these values are money related, so we can just put dollar signs with these to help us compare these. So as we look to compare, it looks like in general the 7th graders raised more money. So we can write that. In general, the 7th graders raised more money than the 8th graders. But the thing with the 7th grade is their variation is also higher. They have an interquartile range of 15 when compared to just 10 for the 8th grade. And so we do need to make a note of that. The variation is greater for the 7th grade which means what? Well, it means the data is more spread out. Data or amounts were more spread out. There was more variation, if you will. So if neither set of data is symmetric, we'll use the median and interquartile range. In our second example, the double dot plot shows the daily number of fruit smoothies sold at 2 different places during a 2-week period. Once again, compare the centers and variations of the 2 populations, and write an inference you can draw about the 2 populations. Now, as we look at these dot plots, neither is symmetric again. So we're going to be using the median and interquartile range. So if we look at smoothies galore, and try to compare that then to sunshine smoothies, we need to attempt now to calculate the median. Now, it's not quite as easy as our box plots. So we need to count the number of data values we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, if I use my little trick to find the median, it's going to be the 14 plus 1 divided by 2 term, which means the 7.5 term. Well, then if I count up 1, 2, 3, 4, 5, 6, 7, that means my median is going to be right here, in between the 7th and 8th terms. What is that median? Well, 70. So the median for Smoothies Galore is 70. What about Sunshine Smoothies? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 terms again. So I can refer to this, it's going to be once again the 7.5 term in between the 7th and 8th term. So 1, 2, 3, 4, 5, 6, 7. It's going to be right there. So the median here is 65. And I can translate that down here, 65. Now what about the interquartile range? Well, we need to find our two quartiles now. And so if we look at the lower half of the data here, there's 1, 2, 3, 4, 5, 6, 7 points. 7 plus 1 is 8. Divide by 2 is 4. So I'm looking for the 1, 2, 3, 4th term, which is right here. So the lower is 60 for Smoothies Galore. What about the upper? Well, again, I have 1, 2, 3, 4, 5, 6, 7 terms. It's going to be the 4th term, so 1, 2, 3, 4. So this term right here, which is 80. So 80 minus 60 is going to get my interquartile range for Smoothies Galore, which is 20. What about Sunshine Smoothies? Well, it's very similar. I have 1, 2, 3, 4, 5, 6, 7 data values on the lower half. And so it's going to be the 1, 2, 3, 4th term, which is 60 here. And then the upper half, I have 1, 2, 3, 4, 5, 6, 7 terms. It's going to be the 1, 2, 3, 4th term, which is 70. And 70 minus 60 is 10. Well, now I can use these data values to try to draw inferences and compare these centers and variations. If we just look, it looks like Sunshine Smoothies sells less per day. I mean, their data is more on the left side of the graph than Smoothies Galore. So let's start there. Sunshine Smoothies generally sells less smoothies per day Now, if we look at the variation, Sunshine Smoothies interquartile range is only 10 compared to interquartile range of 20 for Smoothies Galore. So we can point that out. There is less variation at Sunshine Smoothies. Because of that, we can draw one more inference. We can say that there is more consistency in the amount of smoothies sold at Sunshine Smoothies. So once again, using the interquartile range to help us compare the variations, and looking at the data and the medians to help us see generally how much is sold. Again, Sunshine Smoothies was less for the medians, and so we can say they generally sell less per day. But then we look at the variation and said, well, there's more consistency, though, with Sunshine Smoothies. Now, in our third example, the double box plot shows the number of weekly participants at 2 community center camps. Compare the centers and variations of the 2 populations and which camp has the greater number of participants. Well, now we finally get an example that deals a little bit with symmetry. Notice how this dance camp is very symmetrical. I mean, that's equal to that, this length's equal to this length, this is equal to this, so it's very symmetrical. However, music camp, this box is a little bit bigger than this box, this whisker is bigger than this whisker, it's not symmetrical. So we do have one set of data that is symmetric this time. However, we're still going to use the median and interquartile range in order to compare these. So if we start off once again with music, then dance, we'll once again use the median and the interquartile range to compare these. Our median for music is here at 60, while our median for dance is also at, 60. So what about our interquartile range? Well, for music camp, we're right here, and if we go down, that looks like it's going to be about 65. And we'll subtract away the lower end, which looks like it is at 50. And 65 minus 50 is 15. Now for dance, looks like our higher end is 80, and the lower end is 40. And 80 minus 40 is 40. So what conclusions can we draw using this information? It does appear, looking here, that overall dance camp has the higher number of participants. So we can write that. Overall, dance camp has a higher number of participants. Now, they both do share a median of 60. With that, though, we can look at the interquartile range, and the dance camp has a much higher interquartile range. So let's say that. The camps share a median of 60. However, there is greater variation in dance camp. And we can finish by saying the music camp participation is more consistent. Now, none of our examples in this lesson so far have dealt with both data sets being symmetric, because when both data sets are symmetric, you use the mean and mean absolute deviation. So I do want to show an example of that and how that would look. And so if we just draw two simple number lines, and on these we have, say, 70, 80, 90, 100, and we'll call these grades for test 1 and grades for test 2. Well, if I just make a double dot plot here, and I can say, all right, 3 points there, 1 point here, that's symmetrical. You have 1, then 3, then 1. And then what if you have 1, 2, 1, 1, 2? Also symmetrical. And so now we get to use the mean and mean absolute deviation. And so if we look at our data, test 1 versus test 2, if we look at the mean now, if we add up the data points for test 1, it would be 70, 80, 80, 80, and 90, and then divided by the 5 tests gets us 400 divided by 5 is 80. What about test 2? Well, we have 2 80s, a 90, and 2 100s. And when we divide that by 5, these add up to 450. And when we divide that by 5, we get 90. So the means are 80 and 90. Now what about the mean absolute deviation? Well, if we look at each of our data points and subtract away the mean, 70 minus 80, oops, and then 80 minus 80, 80 minus 80, 80 minus 80, and 90 minus 80. That is 10, 0, 0, 0, and 10. And when I divide that by 5, I get 20 divided by 5, which is 4. So I have a mean absolute deviation of 4 for test 1. What about test 2? Well, the mean was 90, and so I would have the absolute value of 80 minus 90, 80 minus 90, 90 minus 90, and the 2 100s minus 90. And so we would have 10, 10, 0, 10, and 10. Dividing by 5 is 40 divided by 5, which gets me 8. So on average, the test results were 4 away from the mean in test 1 and 8 away from the mean in test 2. And we could compare these, saying on average, test 2 scores were higher. However, there was more variation in test 2 than in test 1. And that is it on this lesson on comparing populations. Good luck.